Hello, and welcome to a new edition of H.E.L Expense with your host, Dr. Mario Torres Rodrigo. And today, it feels like we are bringing you a very special video. For months, we have talked about bioreactors, their history, different types of bioreactors, and more lately, we have been talking about gut microbiome, the kind of microbes that live there, the different parts of the gut. But today, we're going to be giving you our 5 top tips on how to replicate the digestive system in a bioreactor system. So, without further ado, let's jump into the first tip. Choose the right system and right simulation. We know that the digestive system is going to have different chemical and physical parameters that we need to be able to replicate in our bioreactors. So the first thing that we need to check is that our system is going to be able to cope with these conditions. Sometimes it's going to be super low pH or the lack of oxygen. So we need to be able to measure these characteristics. But also the magic of parallel multi-reactor systems is that we can actually replicate all the different parts of the digestive system into individual reactors, and then we can just transfer from one of the reactors to the next, kind of following the same pattern that it would follow on the digestive system. Also, another thing that we need to bear in mind is the kind of simulation we're going to use. Do we want to prefer an static one, which is going to be cheaper, but maybe it's not going to be as reliable, or we want to do a semi-dynamic one that's going to be more realistic, but also more resource consuming? Our second tip is going to be choosing and implementing standardized simulation digestion protocols. Why is that? Well, we know that a very important thing in science is that our results need to be reproducible. If we are using standardized protocols, it is more likely that people will be able to follow our recipes and then replicate the results that we got. And we have discussed about this in previous videos. There's been a massive effort into trying to come up with a standardized and harmonized protocol. And this is how, for example, InfoGest was created. InfoGest will give you the conditions and the type of mixes that you need to add into your simulation in order to recreate the digestive system. The third one is going to be to control environmental parameters. One of the best things about bioreactors is that they are designed to provide ideal conditions. And how is this done? Well, we can actually measure life conditions inside of our vessels. And then using feedback loops, we can control these conditions so they are as similar to what we would expect on the digestive system as possible. And if there are any kind of deviations, because it could happen, then the system is going to be able to compensate adding, for example, acids or bases or gases that they are needed. Some of the critical parameters that we need to control in our simulations are pH, temperature, dissolved oxygen, but also we are going to be adding certain simulated fluids such as saliva, gastric acid, or bile salts that they also need to be added using our system in a controlled manner that is going to be similar to what we would find in nature. The fourth one is going to be choosing the right biological agents. And by biological agents, I'm not only talking about the kind of microbes we're going to add. There are all the biological agents such as enzymes that we're going to be adding. But let's break this down. The first thing is the kind of community we're going to add. There are two options here. We can either have synthetic communities that are very easy to control and very easy to track, and they are likely to give us more reproducible data. However, we know that sometimes these communities are not going to be as representative as we would find in nature. This is because there is a lot of intra-species variability. So different organisms, different humans are going to have very different gut microbiotas, and this is going to also have an impact in our data. Secondly, I have talked about what kind of enzymes we are adding. The digestive system and the digestive process involves a lot of enzymes, including amylases, proteases, lipases, and these enzymes can come from different sources. We know that if we are going to be using human enzymes, these are going to be very expensive. But they're going to be much more reliable in terms of data. However, we can also get enzymes from other sources, such as bacterially produced or in yeast on certain organisms, such as pigs. Maybe they're not going to be as similar to what we would have in our bodies, but this cheaper price is going to be something that we need to balance on. And then our fifth and last one, but definitely not least, is incorporate realistic physical conditions. We know that our body is very good at mixing things. We, for example, use our mouths to chew on the food that we ate, and that's going to generate a bolus that is going to be a very homogeneous mix of the food that we've eaten with saliva, with certain enzymes. We need to be able to replicate this kind of condition also in our bioreactor systems. But also another way that our body has to mix the content is through peristaltic movements. We have that the muscles that surround our digestive system are going to make this kind of movement, and it's going to be pushing the food further down and also increasing this mix. So we need to think at the time of designing our process if we want to use what kind of stirrers or what kind of pumps to be able to replicate this kind of condition. And that's it from me. My name is Dr. Mario Torres Rodrigo, and I'm the applications leader at H.E.L. I hope that you have enjoyed this video, and if you have any questions, if you have any comments, please come back to us. Thank you very much.